This is the yellow LED and the green one.
We designed a voltmeter that can display volt and millivolt on an LCD display. When the system is turned on, the green light also will turn on. And now you can detect the voltage in millivolts. The principle is that each analog signal input port has a file in Linux. We open the file in the user space and read the input value, which is displayed on the LCD display through I2C communication. I press this button and the voltage on display changes to volt. Because there is no Linux header available online, we cannot use kernel to capture the interrupt. So we use the while function in user space to continuously scan the file on the GPIO port and get data from it. Also, instead of using button to switch mode to prevent button glitch, which could cause the button to either not respond or respond twice sometimes, we ask the system to maintain a mode when the button is keep pressed and restore when the button is released. When the measured voltage exceeds 500 millivolts, the yellow LED will turn on. This is the mechanism that protects the beaglebone black and does not allow the input voltage to be too high. So our project has two main problems we have to solve. One is the I2C LCD screen communication with the beaglebone black board, and another is how to transfer the file since we're using the default Linux kernel, which doesn't offer a Z mode file transfer option. It requires a file to do the Z mode transfer, but the default one doesn't have internet, so it's not able to sudo apt install it online. So the way to do it is SSH into the system. There's a app called psftp.exe, and you can SSH into it by open the port, which is 192.168.7.2. This is a normal device. Aside from the PC, your PC probably is 7.1. And you can log in, and then you can transfer file. You can LCD into a folder of your computer and CD into the folder of the beaglebone folder that you want to store the file in. Another thing we need to resolve is the LCD screen communication, which don't provide us a manual that tells us how to control it by bytes. This is because this device is actually designed for Arduino, where they defaultly can use a line in Arduino called LCD init and LCD start, and probably other commands that just can achieve by one lines of code. So we have to look into the mechanism of how we actually do the I2C communication with the board. So we actually find a data sheet online, which is here, that shows that the LCD has pins that correspond to the I2C output, which is in the order D7, D6, D5, D4, and BL enable R, W, and RS. This means that our LCD connection with the I2C pin, which is PCF 85 something, they are actually in the 4-bit mode control. So that is the reason why we have to first initialize the system, and second, we need to enable the system into a 4-bit mode, and then send the command byte by byte.